Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So I wanted to work out some examples. Actually, here's the top of it. Worked examples is the title of this, standard form, conic. So we got 3 problems that I'm going to work out. And you can see them all here. Center and a point on the circle for number 1. 2 vertices and 2 foci, or foci, however you want to say it. I really don't care. And then number 3, the vertex and the directrix. So I don't get too caught up on how things are said, what formulas are supposed to look like, things like that. I try to stay really not technical. So let's just jump right in and look at what this is going to look like. So the best thing to do, I think, for all of these is to kind of like draw these and figure out what they look like. So we have a center at negative 13, negative 10, which is going to be somewhere right here. So negative 13, negative 10. And then a point on the circle, well, that means we have a circle. So it's at negative 19, negative 10. So it's out here somewhere at negative 19, negative 10. Well, if they gave us 2 points and they're both comma negative 10, that means that they actually just gave us the radius as well. So the circle is going to look something like this, more or less. And then that's the radius. Well, it looks like we'd have to go 6 spaces to get from negative 13 to negative 19. Now, you could also find that by subtracting them and then taking the absolute value. If it's negative, just don't make it negative. And that's how you would find that. And all you really need is the center and the radius for a circle equation. So the equation of a circle is going to look like this. It's going to be x minus h squared plus y minus k squared equals r squared. So r is the radius. R is the radius. And then hk is the center of the circle. Well, we know the center. It's negative 13, negative 10. So it's x minus negative 10, which means it's going to be 13, positive 13. And then the same thing for y. Y plus 10, because it's going to be minus k, and k is already negative. So it's minus a negative. 2 negatives make a positive. And then the radius is 6. 6 squared is 36. And there you have it. So for the next one, again, the whole point of this is to find the standard form equation of the conic section, meaning figure out what it is and then make an equation for it. So we need to figure out what it is and then make an equation for it. Number 2 might not be a circle, and in fact, it has 2 vertices and 2 foci, which means it's definitely not a circle. It's something else. Let's see if we can get a picture of what this looks like here. 7, 10, something like that maybe. And then negative 19, 10. That'd be way out over here somewhere. All right, so negative 19, 10, and 7, 10. And then negative 1, 10, something like right there. And negative 11, 10. So something like right there. So it looks like what we have here is actually an ellipse. Oh, I made that way too far out. Let's see if we can do a little better job there. More like that. Okay, so it looks like the foci are on the inside. If the foci are on the inside, that's how I knew it should look like ellipse. If the foci were on the outside of the vertices, if they were out here somewhere, then I would know that it would be a hyperbola. But as it stands, it's not. They're on the inside, so that's how you know it's an ellipse or an oval, whatever you want to call it, little Baymax. So we need to figure out where that is. That's the center, right? You just go to the middle somewhere, and that's the center. Well, where, though? It's going to be something comma 10, because everything's comma 10. If you noticed, everything's comma 10, so it's somewhere in there. And it might be easier to figure out what's in between negative 11 and negative 1. So in between negative 11 and negative 1, if I add them, I get negative 12. Then I divide by 2 and I get negative 6. All right, so just take the simple average there. And you have negative 6 comma 10. So that's my center. And your equation for an ellipse, by the way, is very similar to a circle. It's very, very similar. X plus h squared plus y, I said plus, I meant minus, x minus h quantity squared plus y minus k quantity squared equals 1 this time. And the reason why it equals 1 is because there's two different radii. So if you were to take the circle equation and divide it by r squared, then you'd have like x over r squared and y over r squared. But there's two different radii, one for x and one for y. So instead of calling it r, we call it a and b. But they're both the radii of the ellipse, since it has two different distinct radii, a large radii and a small radii. So we can actually figure out what the large one is pretty easily. We just go from the center out to the edge. Looks like we have to go from negative 6 to 7. So if I go from negative 6 to 7, I'd have to go 13 spaces. Therefore, A is 13. Right, so that's one of our values we need. And then, of course, the center, which was this guy. And now we just need to know what B is. So this one's a little harder. They didn't tell us how far up or down to go to get to these points here. We have to get to this point and this point. Looks like it should be just a couple spaces, not too much. But we don't know just based off of the graph, because all I did was kind of sketch it. So I don't know for sure. But in order to know for sure, what we have to do is we have to actually use the foci. So this distance from here to here is the foci distance, which is C. And it looks like I go from negative 1 to negative 6, which means it has a distance of 5. So C is 5. Okay, well now what do we do with that? Well, there's an equation. It's basically like the Pythagorean theorem, but instead of a squared plus b squared, it's a squared minus b squared. A squared minus b squared equals c squared. And we're going to solve for b, because we don't know b. We know a, and we know c, but we don't know b. A is 13, so 13 squared, minus b squared equals c squared. And now we just solve for b. So to recap real quick, we did a and c. A we knew based off of going from the center to the edge. And then C we know from going from the center to one of the foci. That distance from the center to the foci is C, and the distance from the center to the edge of the circle is either A or B, depending on the problem. In this case, it happened to be A. And now we're ready to solve. Once we know B, we're done. So we're almost there. 169 minus b squared equals 25. And also, if you're really familiar with your Pythagorean triples, this would make this problem really easily. I'm not going to spoil it for you, but this one is a Pythagorean triple. So when we solve this, it's going to be a nice whole number. Minus 169. You can do this in the calculator if you want, or if you wanted to subtract it by hand and you're having trouble, it might help to do 169 minus 25 instead, and then just take the opposite of that answer. So that'd be 9 minus 5 is 4, 6 minus 2 is 4, 1 minus nothing is 1. So this would be 144 equals negative 144 equals negative b squared. So, make them both positive, take the square root. So b equals 12. Now, if you're doing an algebra problem and there's no context behind it, if I take the square root of both sides, I do want to do a plus or minus. But here we're talking about b, which is one of the radii of the oval. So it's a distance, so it can only be positive. So we would just do the 12 number. All right, so now we're done, and we just plug in our numbers. So we would do x minus h. H is negative 6, so it's plus 6 squared, plus y minus 10 squared equals 1, and I'm dividing by a squared and b squared. A is 13, so a squared is 169. And then b is 12, so b squared is 144. All right. So for the last one, let me zoom in a little bit here. For the last one, I have a vertex of 1, 4 and a directrix of x equals -5. So let's look at what that is. So first of all, the clue as to what kind of conic this is that they give you the directrix. If they give you the directrix, it's a parabola. Now, in some cases, they could give you the directrix for a different conic, but 9 times out of 10, if you see them give you the directrix, it is a parabola. And we can also tell because they only give us one vertex here. So that's really only enough information to make a parabola off of. So let's go ahead and graph it, get an idea of what it looks like. 1, 4, 1, 1, 2, 3, 4. It's right there. And I normally don't do the little tick marks, but on this one, it's so small that it's just helpful to do the little tick marks. 1, 2, 3, 4, 5. There's x equals -5. When that line says x equals -5, it means that x is stuck at -5. So every point that's -5, comma something is on the line. -5, comma 0, -5, comma 1, 2, 3, 4, 5, so on and so on. So this is my directrix. Okay, so if you are kind of new to this section, or if you're just still not sure exactly what a directrix is, the way I like to describe the directrix is like this. The directrix is like the opposite. It's like the opposite of the axis of symmetry and the opposite of the foci, or the focus. In this case, we just have one, so focus. So directrix is kind of like the opposite of the axis of symmetry and the opposite of the focus put together. It's like if the axis of symmetry and the focus had like evil twins, and they like got married and had a child. That's what the directrix is. So basically, the directrix is here. Our vertex is here. The distance from the vertex to the directrix is the same distance we would go to get to the focus in the opposite direction, which is why I like to call it the opposite. So I need to go 1, 2, 3, 4, 5, 6 spaces to get to the directrix. So I go 6 spaces to get to the focus. 1, 2, 3, 4, 5, 6 spaces. Excuse me. So it's going to be right here. There's our focus, and that matters because we actually need to know what the focal length is. So you don't have to graph the focus point necessarily. I'm just kind of graphing it so we can get an idea of what the graph looks like. But the length of the focus, which we've been calling C, but they like to call it P, lowercase p for focus. I like to call it C as well, P or C. It really doesn't matter too much. In textbooks and online, they'll call it P for focus. But C for focus makes a lot of sense, though, too, because you use C to find the focus for an oval and for a hyperbola. So whatever floats your boat. But basically, our parabola is going to open like this, kind of out like that. It's usually pretty wide, especially if the focus is really far out like that. So something like that. That's just kind of a sketch to give you an idea. But it's going to open so that it kind of hugs the focus and goes away from the directrix. Now, the directrix is also, like I said, the opposite of the axis of symmetry, because the axis of symmetry is this blue line right here. It goes like that. So the directrix is perpendicular. It makes a right angle with the axis of symmetry. And it is the same distance away from the center as the focus is. So that's the way to remember the directrix. If you put the axis of symmetry and the focus together and their opposites, take the opposite of each one, then that basically gives you the directrix. right? So we have almost everything we need. We really, so let's actually look at what the equation looks like, because that's the whole point of this, is to get the equation. The equation of a parabola, right? So the very first parabola you ever heard of was y equals x squared, probably, which is just a little parabola that opens up, right? Ours doesn't do that, but let's kind of look at the evolution of parabolas as you've learned them. So the first time you learned about it, it was y equals x squared. Then you might have added something to it, some sort of value. Let's just call it k. Then at some point you learn about, okay, well, there could be something inside of here. And then h comma k is your vertex. Then you learn that you can put stuff in front as well, and you get this formula. So this is vertex form, which is why in the instructions they tell you specifically to look for the standard form of the equation of the conic. So there's a different equation to use for that. So don't just use vertex form. I mean, if the program you're using to type it in, or if your instructor doesn't care, then go for it. But the conic section version of this is actually really similar. Let me show you what happens. So we went from y equals x squared, and we've got this so far. If we subtract k, I get y minus k equals a, x minus h, quantity squared. So now we're really close. A actually turns into 1 over 4p. Right? So p is probably what you're more familiar with seeing if you've already been looking at equations for this. I use c when I solve these because it just makes more sense, because c is like the focus value. But you can do whatever you want with it. And that would be the equation if it's opening up, because this is still an equation of a parabola opening up. Now, all I need to do to change that, though, is just say, okay, well, if I want it to be different, I'll just use a different thing. I'll just say x minus h equals 1 over 4p y minus k squared. And that would be for if it opens to the right or to the left, which it does in this case. So that's the version we need. So we still need the center, and we need the focus, and we've actually got both now. We've actually got both. And we didn't need to do as much stuff for this one as the previous problem number 2. They kind of gave us the answer. You just kind of had to count the spaces to get from the vertex to the directrix. And that's your focus length. So at this point, we're basically done. We can just put the answer in and solve it. The vertex is 1, 4, so it's x minus 1 equals 1 over 4p. Well, p is the focal length. So that's 6. I had to go 6 spaces. I had to go from 1 to -5, so 6 spaces. And then y minus k, which is the y part of the vertex. And then quantity squared. It's opening to the right. Right is the positive direction, so we wouldn't need to throw a negative anywhere. It's opening to the right, which is in the positive direction. So then my final answer would be x minus 1 equals 1 over 24 y minus 4 squared. And that is problems 1, 2, and 3. So if you're watching this online, if you haven't already gotten my guide on how to solve a math problem, any math problem, it's a quick guide called the 5 math mistakes everyone makes and how to avoid them. It's free for you if you want to grab it from my website, myersmathematics.com. And if you want to see any other videos on any topics, just let me know in the comments below. If you thought this video was helpful, or if you want to see more videos like this, go ahead and like and subscribe, and I'll see you in another episode.